Next up is Manish. Manish is a data engineer at Tile. He graduated in 2016 summer from the University of Georgia with a master's in CS with specialization in distributed computing and machine learning. Other than data, Manish also loves to talk about vegetables he's currently growing in his backyard.
Thank you. As introduced, I'm Manish. I am the data engineer at Tile. By the way, the use of article the is not a mistake. It's intentional. I'm the only data engineer at Tile, has been that way for a while now. uh, and much of this talk is really not about Tile or data engineering, or it's actually about the community. I have gotten so much help from. I started my talk saying that I am the data engineer at Tile, but it's really about the community people who have built such an awesome tool, and especially the philosophy of the way you think. It's very much in sync with how the developers would think. How do you want to build a data pipeline? Because data pipelines crop up, let's be honest, like every minute, because anything you say, if you have done it 3 times, it becomes pipeline. And you are constantly looking to automate it. So if that just following that philosophy has helped me a lot, and I'm gonna spend next 15 to 16 minutes on just spending time on trying to explain what are the challenges I faced when I choose this product, and if how it has translated into building this really stable data engineering at Tile. So a quick data Tile is Bluetooth tracking devices. These are things which help you find things, not at best of the places, yet we do find them. And this is current daily active users of Tile, 4.2 million active users on a given day. That just shows that the community backup you have when you're looking for your misplaced things. So what I'm going to double down on next on is just the definition of data engineering. And I've taken references from multiple books, and I already see a few eyes rolling. It's like, what is this guy's talking about? I am not going to do that. That's just so boring and just so useless. Because data engineering, let's be honest, is just about what brings money or value or whatever you work for home. And that's how we define data engineering. So I'm going to take you guys a little bit, travel back in time, almost 1 year, 4 months back. And this is what, and hopefully some of you will probably empathize with the situation, where multiple teams, product analytics, marketing analytics, customer care, data science. Tile is uniquely placed that way because you also own hardware, so you will see that firmware analytics also comes into picture. You're also looking at manufacturing data, where the data is coming from, who is it getting delivered to, so that analytics also is in picture. And then, of course, you have this engineering analytics where you're trying to deliver. So there's this imaginary data engineer who has to sit, which is me, who is just hired, and has to somehow manage all of this. So also, I wanted to also give you guys a landscape of what exactly the data landscape looked like then. So I'm talking about just adding almost 40 to 60 billion records on a given day. A lot of it is location data, as you would anticipate, because effectively we are Bluetooth tracking devices. What else would you track if not location? So now this page would look very familiar. This is typical, multiple type of logs, what you in general are gathering from different sources. Of course, the frequency at which you're collecting it make it a little bit more complicated problem. So when I joined, it has just bunch of, so imagine the picture I showed you on the slide before. There's this bunch of analytic teams which are basically looking for whatever to, just to how to get their work done at a quickest pace. And that's a very typical format for a startup which has seen a spurt growth in last couple of years. So when I entered, there are cron jobs, there are Python scripts with sleep statements, who sleep somehow, sometime even for a day, just to bring them. We have our old friend Jenkins, which is also doing some of the CI work. And then we have our very, cron tabs. And then we had just signed up to this product called Databricks, which would kind of had its inbuilt scheduler. So it will also try to pull in data. And that was the, and there was one data scientist who had also introduced Airflow, but there was just one job which will run every day, just one job, one DAG, and which has just 3 tasks on it. So this is what we started with. So my first, so of course, when I did the market at that point of time, the dev research, what you do, and try to understand that the systems which are available right now, which of these systems would really make sense for me to be able to not only build upon, but manage upon as well. So, of course, as I started the talk with saying that Airflow philosophy was so simple, yet so stunning, because it just so much in sync with how you would think about building a data pipeline. So, Airflow was the chosen one. No reason why I'm standing here and talking about it. So, very first task, bring everything on one platform. That's how it's going to work out. So, okay, everything is on Airflow, everyone is happy, is it? Never, really. So that's when it gets to the phase 2, where you have this constant barrage of, these Slack messages. My data is not synced, my data is not latest, my Hive's partition fails, my sensor fails, what are you doing? I can't see my data. And more often than not, since these data are also going to analytics DB, which is basically there are the reports which are running all the time on it. And since the reports are running, those reports are directly being pushed to execs who are presenting them on real time sometime to either board members or to anyone who is interested in using Tile as a service platform, whatnot. So the moment you see a graph going down, and not really for the good or bad reasons, not always for the bad reasons, you don't want to create. The first thing I learned is data engineering is also about a little bit of perception, because you do not want people to think when there is a problem. No one should just say, looks like data platform is broken, looks like there is a problem with data. That you have to make the platform stable enough that before people say that looks like there's a problem with data, they go back and check that if it's really the data platform which is broken, or is it really the numbers. Because in noise, you may lose some of the analytics, especially if you're a small company, you will lose some of the insight which actually matters for your company. So that was the time I started really thinking about. So I left these 3 points. Basically, how I want to design this new phase of Airflow centered data engineering. So I knew one thing was very clear in my mind, that most of these issues are coming because there are issues. If you are pulling data from, of course, many of us for marketing especially, or for sales, or there are multiple third-party services from where you're pulling data just to know how well or how bad are you doing. So you have this third part, n number of data sources from where you're bringing in the data. So you want to know the API or data source availability at a given point of time, of course. You want to know about metadata quality, and you also want to know about the data quality. This is this is in the gathering phase of it. Once you have gathered all of this data, we use Apache Spark as our common platform to run it. And once you have gathered all this, there are 2 things I was interested in knowing. Number one, was my job even successful? Number two, if the job was successful, how much time it took? In what order? Because ROI is important. You don't want the job which brings no ROI or very little ROI, taking 30% of your entire cluster time. Because let's be honest, EC2 is charging you money by per minute, right? Now, so you are paying money for all these queries or everything what you're running on it. So you want to be able to monitor that and basically come up. And so I'm saying this, I'm trying to paint the picture the way I was thinking and was trying to build the ecosystem. And then I'll superimpose this idea onto something which is actually functional at time. And then at the end, you have this analytics DB where you have pushed your fact, FCT data, DIM data, or the aggregate ones, which other teams have contributed to, maybe analytics team have contributed to. And you again want to know about the metadata quality and the data quality at the end. So I'm sure many of you are familiar with this picture. Many of you have seen this Mars and Warren really nice read big data book. And we'll not be spending any time on the streaming side of it. That's a talk for some other time. But for now, I'll just focus on the batch. And now the Airflow idea I'll superimpose. So we are using Airflow for all the data gathering. As I mentioned, I'm also using Airflow to understand more about my S3 uses at the moment. I'm also using Airflow for the Spark job execution. And as I said, I wanted to understand how this ROI feeds back into how well time is being taken by the clusters. We use mode typically for the UI side of but what we have done to make it a little bit of fail-safe is we have made our Hive meta store like external DB. It's just a RDS instance taken over. So that takes care of some of the weird stuff which may happen if you use update or deletes in your queries, because RDS is always backed up. So that's how we have taken care of some of those problems. So this was a superimpose. So I spoke about 2 to 3 times about that we have built a data quality watcher. So what does the data quality watcher looks like? This is a standard diagram of collecting data from n different sources, bringing it to Apache Spark really to do the transform, and then loading that to Analytics DB. There are people who are looking at these graphs, and depending on what charts they are seeing, there's those emoticons basically. The system which I wanted to design, this was, by the way, this was done also partly by one of the intern we had, high school grad Ben, who was super excited about coding and really good at converting ideas into code. So we built this together on understanding. So the design philosophy for this was, number one, the system has to be cheap. Number two, it has to work. Number three, once the system works, and if the system is cheap and it works, it should also as flexible as we could, because just the variety of data sources which you expect on a given day, you don't want to invest too much into a system which is very much coupled with just how you don't want to build those definitions yet. So this was the goal we came up with. So this is how we imagined, irrespective of where the data is, it could pull data from the third-party services, it could pull data from the load side, or it could pull data from the Analytics DB. But that idea seems a little weird, because you cannot be pulling in all of that data to a separate device, because that's just taking too much of space, or it's also a replica of data which serves no purpose. So sampling, we went the sampling route there, and that was our solution for then. Is like we will be bringing a sample of data depending on how critical the data is for the business. And once that data is in, how do we want to? And then there is this imaginary algorithm, which I'll be talking next about, which runs on it. And effectively, this algorithm should be able to convert that data into some numbers, and then effectively we have this Grafana which can be used and piped in for the users to be able to see it. So I spoke about it. Let me paint a picture of it, what that algorithm looks like. I really imagined it in terms of a tree node, where basically, so if I give you an employee name and age CSV file, what are you looking at? If you had to do this parental verification, you'd say, oh, I want the names to be a string, I want the age to be an integer. If you are a weird type of company and you would say, oh, I want the name to be a string, but I want the first name to be always Manish. That is the only customer I'm going to accept. That's okay. So you could build all that rules, and that is how we design. So all you write is a condition file where you say, this is what I want from my data sources. And effectively it translates into, if I just take the right side of it, so on the right side of tree, you see there are in total 15 total data points. And on the right side of it, you see the one which makes it to the leaf node are the quality data. Anything which remains before that basically are the conditions which failed. And that gives us a very quick preview of where exactly the problem lies. And this is something which I picked up from a few days back from the production. So this basically says that, hey, your location data suddenly saw a 10% drop. And that what we also do is, so this is the whole vertical width of it shows that uh, how many node are on the leaf node, and then what are on the level before. What we do is we sort it based on what is the maximum number, because you want to know that the one factor which is affecting your data quality the most. So that's the red bar. And then it's basically, of course, then you're not gonna spend time on this Grafana. So you want this system to basically tell you if there is something worth looking at. And so here is a alert from me, because I just configured it using my Slack account. It says you have received 16% less data in last hour, and that is something which is actionable item and something we need to go and work on. uh, I'm working hard on getting this small tool what we have built for data quality, on making it open source. Mostly I'll be doing it toward the end of December, because I'm just one person and we have to take care of the Thanksgiving and all the holiday season coming in. But mostly you would see this toward the end of December, and the operating cost for this system to run at the moment, especially for data volume of 40 to 60 billion data count, is $30 to $50 a month. So at the end, in the process, like you guys said, there are multiple sensors we wrote and operators we wrote. I'll not get into detail of all this, but these are few things. These are just few things which I find worth mentioning, other than bunch of things. I wanted to conclude this talk with bringing you guys back to the same picture which I started with, where we have this bunch of teams which are working with different preferences. We are working with understanding how exactly they want data to bring in, and Airflow brings all of them on one platform. It brings a solution which is understandable, and when you are one person, or when you have a slim or a really lean team, what you really want is to educate people around you so that they come back to you with more precise problem. So you don't spend time on debugging. You start where it hurt, like where exactly you can start fixing it. And Airflow has been that tool for me, where it helps, where people, they look at their DAG and then say, I think that is that data that day I have a sync problem because the schema has a mismatch. Now that gives me immediately, that puts me in a position where I am ready to fix it, because that flexibility and that feature has been provided by this. So I'll end the talk with saying a big thank you for what you guys have created, and it's so much in sync with how our developers mind work. And just because the tool is so awesome, I have been able to take this load of this whole company's data engineering and being able to still provide a solution which works for all. And that's the end of the talk. And if there are questions.
Questions?
I think to make a working Airflow for your company, I'm wondering how much do you customize to make it exactly working? I'm guessing the environment should be multi-tenant environment, right?
Sorry, what was the last part? Other than
I guessing the Airflow instance or some multi-tenants.
Yeah, so Airflow works out of the box. Let me just put it out there. You do not have to customize a lot. What I did ended up doing was writing a lot of operators and sensors which made sense to my environment, and plugins in some cases. But the core Airflow, no, I didn't have to change per se. I did added plugins and added more UI part of it, because I wanted, you follow a theme where all the monitoring parts should stay at one place, all the scheduler parts should stay at one place, where people are not just confused between UIs. But that's about it. Most of it is.
How about the permission control?
Sorry?
Access control.
Access control is it's sorry about access control is I just use Google validation, which Airflow provides again out of the box, and we restrict that based on the domain name, because we just want the people inside the company to be able to use it. So that's about it. All right. Thank you. You have been awesome, audience.